So in the first analysis run, we're going to use a finer mesh. So let's check. Let's go to details. So we're going to go with finer mesh. We have 15,000 nodes and maximum aspect ratio 4.6. Let's exit and let's run our analysis. So now we have here stresses, displacement and strain. Here we have our minimum stress, maximum strain, yield strength. Let's go right click on the stress and let's go chart options. And let's see where we have maximum stress. So the maximum stress we have here on this hole, as we had in the previous section when we were using the hole model. Like this. Now let's go to results. Let's define factor of safety plot. Let's click OK. And now we see that we have 2.4 factor of safety. And we had in the previous section, when we were using hole model, we have 2.26 minimum factor of safety. Now we are sure that this is more accurate result because we have higher quality mesh now. So let's go to factor of safety, right click, chart options, and let's go show minimum annotation. So here it is, where we have the highest stress. Now let's go to our mesh again, right click, create a mesh, let's click OK. And let's go here with 4.9. So now we're going to use the same mesh parameters as we used in the previous section. Let's click OK. Like this. Let's check our mesh details. So now we have 8,000 nodes and 4.7 maximum aspect ratio. So now we have 2 times less element nodes and we have the same aspect ratio. So let's exit and let's run this study. Like this. Now let's check where we have our maximum stress. It's still here. Okay, now let's go to factor of safety. And we see that we have 2.27. Now if we compare the analysis when we were working with a whole model and analysis when we work with a half model, we got the same, pretty much the same factor of safety. But if we use the finer mesh, then we got factor of safety 2.4. And we can conclude that the factor of safety of 2.4 is more accurate because we had better mesh quality. But looking overall, the planar symmetry is really powerful tool where you can save your time or you can increase your mesh quality. And now let's go to stress. Let's double click on the stress and let's show the animation of this model. So let's right click on the stress and animate. Let's stop the video now. Let's choose this face and let's go normal 2 like this. And now let's turn on animation. And now we see that the formation is sliding along symmetry plane. So it's not crossing the symmetry plane. And this is because of the restraint that we put here. So the deformation, it doesn't go to left or to right. Okay, let's go back. And now, for example, we want to show the other half of the part. And now we used only half of the part to create a study and to gather results. But now we want to see the whole model. So we can go to stress, right click. We have chart options. And let's go to definition. And here we have advanced options. So let's open this. And let's check display symmetric results. And let's click OK. And now we see the whole model. But this is only virtual counterpart. So now we can see what would happen across the full model. But when you create a report, you must state that this is half symmetry model and that the other half is virtual. So now we can go to stress, right click, and let's animate. And now we can see the animation of the full model.